So sorry. Yesterday we discussed about Spark components, majorly four components. What are those? Five components we have. Spark core. One more.
Spark
ML,
SQL.
SQL. One more.
Spark ML,
Next.
Spark Graph.
Yes, Graph X. Actually, Graph data, the library name is Graph X. And for streaming data, I have
Spark Streams.
Spark Stream. Especially for data engineers. 1, 2, and last one, Spark Stream. These three are important. For data scientist, 1, 2, 3 are important. Okay. But we will learn all the stuff. Especially in Microsoft Fabric for streaming, we have Spark real-time stream. Okay. There also internally, the Spark streaming internal code is used.
Okay.
First, come to the Spark's core. Already we discussed about it. What is a core engine? Like it uses which engine?
RDD.
One engine.
DAG. Okay.
DAG engine. So what is the responsibility of it, DAG?
It will
Prepares execution plan. So yesterday I have given you some code. Just look into the yesterday's part. This is the case, sir. Look at the first statement is reading data from sales.txt. Second file is reading data from sales2.txt. Is there dependency between these two objects? There is no dependency.
No
so
dependency.
that execution plan will be like this. RDD1, RDD2 both will be parallel. After completion of RDD1 and RDD2, then only RDD3 will come into the picture. On that way, that execution plan will be prepared. Okay. And also, not only preparing the execution plan and monitors the flow. Monitors. So, data flow execution. So here the API used is RDD API. So this is first component. So what is RDD?
Resilience distributed data.
Okay, that is abbreviation. Resilient distributed data sets. So simply, in general terms, you can say Spark data objects are called RDDs. So what is RDD means? RDD is a collection of partitions. The collection of data partitions. So these partitions runtime loaded into RAMs of different worker nodes of the cluster. Worker nodes of the cluster. So first, before going to the style of execution flow, first is how to create basic RDDs. What are all the different ways we try to understand? We have three ways to create RDDs. Way number one. When you parallelize local object, a new RDD will be created. When you parallelize local object using Spark context, a new RDD will be created. This is way number one. Just up to now, a small technical demo. I am coming to the portal. Oh, because this ID is not, this account is not mine. Again, I need to contact that person. Or is there anyone like who are ready with this Microsoft Fabric? I will share you the screen and you do implement.
Sir, I have.
So just you Nitin,
I
you
will.
right?
Yeah, yeah.
Yeah, I'm making you host. Now you please share your screen.
Okay.
I stop my screen.
Hey, you can log in. I will share the details. I will accept the request.
Okay.
It is
Then you
better
stop your
because,
screen. I will log in from my side.
yeah, sure.
Yeah. Come on. Hmm. Now it worked out. Okay.
Oh, okay.
Okay. Okay. This is my Fabric portal's homepage. So observe here, my workspace is a default workspace. So if you just click on the workspaces here, come on, tell me the list.
माझा चष्मा रे
Hello? Sir, all of you, please mute, sir. I'm coming to my portal. I just listed my workspace list. I have 3 workspaces right now. One is my workspace, that is default workspace. Later, I have created a MRS, VS, or practice demo. So how to create new workspace already have seen. So if it is the first time, just click on new workspace, a workspace will be created. Okay. But every workspace you cannot activate it because this is a free trial. That's why generally I go with this my workspace. I'm choosing this my workspace. Already I have 2 lake houses here. Number one, my big lake. Second one, something like RSVS lake. Similar to that, you want to create your own workspace. Okay, I take every screen copy. Now step is create a new item as Lakehouse. Look into this, how we are creating a Lakehouse. New item. Within this new item, there are many items are like a copy job, data flow gen for transformations, event stream for real-time data. But we need now Lakehouse. Search for the Lakehouse here. Under store data category. Okay. Here we have Lakehouse. So observe the navigation from the workspace, new item. Under new item, you are going to select Lakehouse. I selected Lakehouse here. Asking Lakehouse name. Suppose I am giving your big lake. So you can choose the workspace. So currently, this thing I selected, my workspace I have selected. Lakehouse name, remember. Your big lake. Just create it. Now separate Lakehouse is created for you. Now just by seeing this basic architecture, basic hierarchy, you can say one difference between data lake and Lakehouse. Anyone please try? Difference between data lake and Lakehouse.
Start with sample data.
If it is Lakehouse, sir, that is a distributed file system in the cloud. If it is not Lakehouse, data lake means that is a distributed file system. It contains only files only. Whereas Lakehouse contains
Lakehouse
files
contains
and also the delta
tables.
tables. Clear? So that all the raw files you can dump here and all your business warehouse related tables you can dump here. Got
Yeah,
it?
Lakehouse is a combination of data warehouse and
Uh,
the data lake.
yes. That too in the delta format. Because of delta format, what is the advantage?
Like insert, update, all the asset transactions also.
All acid properties. At the same time, you will be getting versions for every change activity.
Yeah.
Because of versions, what is the advantage? Time traveling. Okay. So when I step into the complete delta features, I will touch each and every topic. For now, I'm going to create the notebooks. Okay. Now Lakehouse ready. This is what your first step. Once workspace activated, create notebooks. Sorry, create Lakehouse. Into the Lakehouse, what are the files that you need? Like you can upload it. Okay. And come here on the top menus, observe. First one is what? Get data. So that for local files, you can upload here. And observe the third tab here. Open notebook is there. Okay. So this option. Entire screen I am copying. What to do, I will write here. Choose open notebook. Especially the third one, sir, here. I am choosing this. Observe here. Existing notebook and new notebook. I am going for new notebook. Because first time you are going to create a notebook, that's why go with new notebook. Of course, in my workspace already some existed notebooks are there. Go to new notebook. Let's do now. Okay. So this is similar to the Jupyter or similar to your Databricks notebook. Like this, Fabric is providing a notebook. So what environment you can use for the coding here? Observe what are the different options are available. First, I will take this empty screen. Notebook will run. Of course, new we have created. Look into this option, sir. PySpark default option here. Okay. And second, Scala. Third, purely Spark SQL. And Spark R. That means Spark with R language, that is called Spark R. And pure Python you can use without Spark. Pure SQL, like in SQL server, we are using TSQL. Pure as a TSQL you can use without PySpark. But to deal with the big data, we are coming to the PySpark. Whenever this is selected, of course, by default, this is selected. So when you run the first cell, your notebook will be connected with the Spark cluster. Okay. Runtime, the Spark cluster will be allocated for you. Got it. So I take this script. Choose PySpark option. And I am testing the first cell. Just say some normal statement. Print hello. So it is connected. Now it has connected. Okay. Okay. It's just for test. Next work. Yes, see, to work with RDDs, you need Spark context. When our notebook is ready, notebook is on, the Spark context will be ready for you. The name of the object is SC. Just look into this. This is confirmation for you. The Spark is available. You are connected with the Spark. Look at this information, sir. Version 3.5.5.4, which is almost latest. Okay. And master is Yarn. Actually, in Hadoop, master server, that means master nodes, worker nodes will be there. The master service is called YARN. On top of this ARN, the Spark is run. Okay. So internally, Hadoop infrastructure they are using the Microsoft Fabric. Okay. Internally, they are using that Hadoop architecture. That means Hadoop cluster. On top of the Hadoop cluster, they built this Spark. It's their headache. We need not to worry about Hadoop cluster, Spark cluster, how many nodes are there. All these things doesn't matter for us. Now, for now, the confirmation, we are ready with Spark. Now, come back the three ways to create RTD. I repeat way one. What is that? When you parallelize local object using Spark context, a new RDD will be created. Get ready for this. In another cell, let's take one simple example. A equal to 10, 20, 30, 40. What is the type of A, sir? Tell me.
List.
East.
List. That is your local Python local object, right? That is not RDD. Okay, I want to convert this. I want to convert this into RDD. Here A is a list. To make them as RDD, observe next cell of code. R1 equal to SC dot parallelize. Parallelize of. Now what is type of R? Just confirm this. What is this, sir? RDD now. So here R1 is RDD. But what is RDD? RDD is a collection of data partitions, right? How many partitions are here? To confirm that, R1 dot get num partitions. Now check this. How many partitions are here for the R1? When I convert local object, into RDD, here Microsoft Fabric is giving default eight partitions. What is the data in those partitions? I want to check. Observe the statement here. R1 dot glow dot collect. Just verify it. Later I will explain each and every statement. Just observe what is happening. Tell me, sir, how many partitions previously it has listed? Just by seeing this output, you tell me.
8 it listed before.
Eight. But
Eight.
in how many partitions data is there?
Only
Four.
2, 3, 5.
5.
1, 2, 3, 4, 5. That means one partition is taking one value. This is bad way, right?
Yes.
Okay. I want to control number of partitions. Again, R1 equal to, or else R2 equal to, R1 dot coalesce. Because of small volume, I want to make this as only one partition. If it is big volume, multiple partitions will help me. If it is small volume, I don't need 8 partitions or 10 partitions. Very small volume, only 5 values. I want to keep 5 values into one partition. So here I am using a transformation called coalesce. Coalesce controls number of partitions. It reduces number of partitions. So just R2 dot get num partitions. Confirm this. How many now? All of you upload this. Now we have one partition. Suppose I want to make this as 2. Just say coalesce of 2. Now confirm this. Now I have 2 partitions. Got it? Let me keep this. Okay. Now check the data of those partitions. In which partition which data is available? You want to check R2 dot globe dot collect. Now look into this. How many partitions I have? two partitions. In the first partition, only two values are. In the second partition, three values. So when I run some process on this RDD runtime, these partitions are distributed into different machines. That means different nodes. The two into the RAMs, because in memory computing. Got it. This is the first way how to create your RDD. So I want to keep this as one partition only. Tell me now. From your side, you tell me. I want to make this as one partition. I am bringing into the original R1. R1 dot. Tell me, sir. Coalesce. Stop.
One.
Now R1 dot get num partitions. Okay, we have one partition. Main statement here, our way number one. How to look into the way number one. Way number one is when you parallelize local object using Spark context, a new RDD will be created. Come to the R2, that is way 2. When you perform some transformation on RDD, on existed RDD, when you perform some transformation on existing RDD, a new RDD will be declared. This is second way. Let's try to understand this second way. Look at your R1, sir. When you say collect is the action here. When you perform this collect action, data will be collected from the Spark cluster. Okay. And a local object is created. Now this output is local. R1 is RDD, but R1 dot collect output is not RDD. This is local. That means Python list. Okay. Now on the R1, I want to perform some transformation. What statement I am using, just forget it. I am going to perform a transformation now. R2 equal to R1 dot map. Whenever I want to perform some operation on each element, I use map transformation. Lambda x. Here x represents each value. For each value, I want to add 100. So this is a transformation I perform. Now just check what is type of R2. R1 existed RDD. On the R1, we perform some transformation so that R2 created as RDD again. But observe here, pipelined RDD. What is the meaning of it? It is saying pipelined RDD. What is the meaning of it?
It is created from R1.
That means derived from some other RDD, right?
Yeah.
Yeah, that means R1 is treated as a root. R2 derived from R1. Check the data of it. R2 dot collect. Now R1 is RDD, R2 is also a RDD because I performed some transformation on it. Okay. Let me take copy of the previous statement. Here R2 derived from R1. So R2 is also a RDD, but simply called as pipelined RDD. Got it. Again R2. On R2, I am going to perform some other transformation. One more transformation I will apply. Just observe what happens. R3 equal to, this time R2 dot filter. Lambda x. Here x is each element. I want greater than 130 values. X greater than 130. Some filter condition I applied. Filter is also a transformation. On existed RDD, you are performing some transformation so that a new RDD will be created. Now check type of R3 again. Is a pipeline RDD. That is derived from one more RDD. That is the meaning of it. I am saying R3 dot collect. So only two values selected into this one. Clear? This is second way. So try to look into the second way once again. When you perform some transformation on existed RDD, a new RDD will be declared or created. Now look at the major thing. Way number 3. When you read data from a file, using Spark context, a new RDD will be created. Okay. Just observe, I am going to upload one file here. Still I am in notebook, this no same notebook only. Go to your lake house. What is your lake house you created? Your big lake. Here you have upload files option is here. Or else like a under get data, upload files. Suppose you want to load data from other databases into this one, you have to create a pipeline. Okay. For now, we are going with local to this fabric, upload files. I write the steps. The practice steps follow the same sequence. Okay. Now go to Lakehouse. What is your Lakehouse? Your name is said your big lake. And choose upload files. Get data. Get data to upload files. This is the option. So here I am selecting upload files. Let's select one simple file. BMP. Click on upload. If file exists, I want to override it. Of course, we don't have any files here in this lake house. Simply say upload. Upload it. Just confirm here. Under your lake house, there are two options. One is tables. Second one is files. Just click on the files. You will see this here. Now I want to read this file. But to read this file, I need path. To get the path, just first let me copy this. General statement is like this, sir. With the Spark context you want to read means the general statement. SC Spark context dot text file. Under text file you are giving your file path. But backend of your data, the Lakehouse files is backend data lake. How to get the data lake file is just to simply drag it. First I keep this. Okay. Go to Fabric. Go to your notebook number 4. Open our big lake. Take that file. No content. Just now we uploaded file. One minute. Where is close option for this? Here it is. I just refresh it. Under files, EMP1. In which cell you want to use, go to that cell. Here. Just drag this file, you will get a path. Okay. Drag the file into notebook cell. But it is giving a Spark data frames API. But I want to work with RDD API, Spark context. I take only this path. This is the backend file path. That means if I load some file into Microsoft Fabric internally, where it sits in the data lake only. So this entire path I am taking. Look into this path. ABFSS. This is the protocol for this data lake. Okay. And look at this file. So this is your folder. Under folder, you have the file emp1.txt. So in this path place, I keep this file. Okay. I want to make it as RDD. Let's say EMP equal to, this is my statement. Okay. SC dot a text file and then give your path. Some single quotes extra here. I am removing. Just to run this. But your Fabric has given you spark.read. This is actually data frame API. For now, you are not going to use the data frame API. I'm going to use Spark context. That means RDD API you are using. EMP equal to sc.text file and give the path of it. Okay, I'm running this cell. And now check what is the type of this EMP. This should be RTD. This is third way of creating RTD. Got it? I keep previous statement into my notes. Create RTD with file using Spark context. This is whatever third way. After that, confirm it whether it is RTD or not. Type of EMP. What data is there you want to check? I have 11 records, 13 records in that file. emp.count. In my file, there are 13 records. Yes, perfect. And what is that data? emp.collect. You want to get the data from the RDD? Just say emp.collect. Understood?
Sir, how many partitions it has taken? Can you check?
If it is from file, generally it takes 2 partitions. From the local object, it takes 8 partitions. Generally, it takes 2 partitions from the file. Let's confirm this. How many partitions? emp.get num partitions. emp is already now. From that, you are taking how many?
2.
2. Because small value.
Is there any limit, sir? Minimum, maximum?
No limit.
Minimum it can take 1 also, maximum can
Yeah.
take it.
So generally, suppose if by default it takes 1 means there is no concept called parallel process, right?
Yes, yes. Minimum 2 it has to.
Minimum 2. Like
Maximum no limit.
maximum any. Okay. Okay, what are the statements I have used additionally? emp dot collect. After that, you used emp dot count. After that, you applied emp dot get num partitions. So in this way, you can do this. So finally, recall all the 3 ways. You tell me, please. Totally 3 ways you have seen.
Local one. First one is local
First one,
local parallel.
parallelize local object using
Spark context.
Spark context. Simply say SC. Second one,
Transformation.
perform transformation on existing object. Third way,
Reading.
read data from file. File or table, whatever it may be, okay? Read data from file using
Spark context.
Spark context. So these are the 3 ways. This is fundamental work in the Spark. Got it. Later we play some little play with this RDD in the next class, maybe on the Monday. Then we come to data flow execution style and how, if any failure happen, how fault tolerance is applied, because all these things are very important for interview. If you go to the interview, the 90% of your major concentration is on in this PySpark part only. Okay. So, but same PySpark we are playing on Microsoft Fabric. Step by step, we will understand everything, right? So this document already I kept in the third place. Fabric notebook here complete is RDD creations. So final today's agenda is what are all the different 3 ways to create RDDs. Yesterday just a Spark introduction. The before day, the Spark account setup. That is account setup in the Microsoft Fabric. Okay, already these notes with you. If anybody missed, please collect these notes. వినయ్ గారు, ఇది మైక్రోసాఫ్ట్ ఫ్యాబ్రిక్ అనేది జస్ట్ 4 days అవుతుంది స్టార్ట్ అయ్యి. ఓకే, ఫస్ట్ 3 days అంతా థియరీనే, లాస్ట్ 2 days నుంచే ల్యాబ్లోకి వచ్చాను అంతే. అంటే బ్యాచ్ అంటే ప్రతి బ్యాచ్కి పైథాన్ తోటి ఎస్క్యూఎల్ తోటి అలా స్టార్ట్ చేయమన్నమాట. ఇట్స్ కీప్ ఆన్ సైకిల్. సపోజ్ మీకు పైథాన్ రాదు, వెన్ నెక్స్ట్ పైథాన్ బ్యాచ్ ఇస్ దేర్, అటెండ్ పైథాన్ సెషన్స్. సో బట్ ఈ సెషన్ అనేది మ్యాండేటరీ మీకు. Okay, sir, all of you. So get ready for attending the machine learning session. By 8:45, we'll join machine learning. Thank you.
Sir, class recordings will be uploaded already.
అప్లోడ్ ఐ థింక్ ఆల్రెడీ అప్లోడ్ జరిగిపోయింది అనుకుంటాను నిన్న. సరే సార్, తేజస్విని వీళ్ళతో మాట్లాడండి.
Okay, sir.
లేదంటే నేను కూడా కనుక్కుంటాను ఒకసారి.
Okay, sir. Thank you, sir.
యా రైట్.